A marine heatwave is a period of abnormally high sea surface temperatures, SST, compared to typical temperatures for a particular season and locale. 1. Marine heatwaves are caused by a variety of drivers. These include short-term weather events such as fronts, intraseasonal events, 30 to 90 days, annual and decadal, 10-year, modes like El Niño events, and human-caused climate change. 2, 3, 4. Such heat waves affect marine ecosystems. 5, 6, for example. Heat waves can lead to events such as coral bleaching, sea star wasting disease. 7, 8. Harmful algal blooms. 9. And mass mortality of benthic communities. 10. Unlike heat waves on land, marine heat waves can extend over vast areas, persist for weeks to months to years, and extend to subsurface levels. 11, 12, 13, 14. Major marine heat waves affected the Great Barrier Reef in 2002, 15, the Mediterranean Sea in 2003, 10, the Northwest Atlantic in 2012, 2, 16, and the Northeast Pacific during 2013 to 2016. 17, 18, these events had drastic long-term impacts, 10, 19, 9. Scientists predict that the frequency, duration, scale, area and intensity of marine heat waves will increase. 20, 12, 27. This is because sea surface temperatures will continue to increase with global warming. The IPCC Sixth Assessment Report, SR6, in 2022 stated that marine heat waves are more frequent, more intense and longer since the 1980s, and since at least 2006, very likely attributable to anthropogenic climate change. 21. 381 th confirmed earlier findings in a 2019 IPCC report that marine heat waves have doubled in frequency and have become longer lasting, more intense and more extensive. Very likely 22. 67. The 22 report predicted that marine heat waves will become 4 times more frequent in 2081 to 2100 compared to 1995 to 2014 under the lower greenhouse gas emissions scenario, or 8 times more frequent under the higher emissions scenario. 20. 12, 14. Definition. SR6 defined marine heat wave as a period during which water temperature is abnormally warm for the time of the year relative to historical temperatures, with that extreme warmth persisting for days to months. The phenomenon can manifest in any place in the ocean and at scales of up to thousands of kilometers. A 2016 study defined it as an anomalously warm event that lasts for 5 or more days, with temperatures warmer than the 90th percentile based on a 30-year historical baseline period. 23. The term was coined following an unprecedented warming event off the west coast of Australia in summer 2011 that led to a rapid dieback of kelp forests and associated ecosystem shifts along hundreds of kilometres of coastline. 24. Categories. Categorization allows researchers to compare event drivers and characteristics, geographical and historical trends, and communicate about them consistently. 25. Marine heat waves are classified via a naming system, typology and characteristics. 23. 25. The naming system involves locale and year, for example Mediterranean, 2003, 2510. Events are rated on a scale from 1 to 4. Category 1 is a moderate event, Category 2 strong, Category 3 severe, and Category 4 extreme. The category is defined primarily by sea surface temperature anomalies, SSTA, later adjusted to include typology and characteristics. 25. They are further classified according to the degree of symmetry, duration, intensity, max, average, cumulative, onset rate, slow-fast, decline rate, locale and frequency. Various combinations have been observed. 23. While marine heat waves have mostly been studied at the sea surface, they can also occur at depth, including at the sea floor. 26. Drivers. The drivers for marine heatwave events can be broken into local processes, teleconnection processes, and regional climate patterns. 2, 3, 4. Two quantitative measurements of these drivers have been proposed to characterize marine heat waves, mean sea surface temperature and sea surface temperature variability. 25, 2, 4. At the local level, marine heatwave events are dominated by ocean advection, air-sea fluxes, thermocline stability, and wind stress. 2.27. Teleconnection processes refer to climate and weather patterns that connect geographically separated areas. 28. The teleconnection processes that play a dominant role are atmospheric blocking subsidence, jet stream position, oceanic Kelvin waves, regional wind stress, warm surface air temperature, seasonal climate oscillations, and nearby cyclones. 29. These processes contribute to regional warming trends that disproportionately affect western boundary currents. 2. Regional climate patterns including interdecadal oscillations like El Niño Southern Oscillation, ENSO, have contributed to marine heatwave events such as the blob in the northeastern Pacific. 30. Drivers that operate on the scale of biogeographical realms, or the Earth as a whole, are decadal oscillations, including Pacific Decadal Oscillations, PDU, and climate change. 2, 4, 31, 607. Ocean carbon sinks in the mid-latitudes of both hemispheres, and carbon outgassing areas in upwelling regions of the tropical Pacific experience persistent marine heat waves. 32. Scientists predict that SSTs were expected to increase, along with the frequency, duration, scale, or area, and intensity of marine heat waves will increase due to climate change. 33, 20, 1227. The extent of ocean warming depends on emissions mitigation efforts. More greenhouse gas emissions and/or less mitigation push SSTs up. Emission scenarios are called Shared Socioeconomic Pathways, SSP. Higher number imply higher emission levels. The low emission scenario, SSP 126, would trigger an increase of 0.86 degrees Celsius, while the high emission scenario, SSP5 8.5, would be as high as 2.89 degrees Celsius. 393. Marine heat waves are predicted to become 4 times more frequent in 2081 to 2100 compared to 1995 to 2014 under the low emission scenario, or 8 times more frequent under the high emission scenario. 1214 mathematical model CMIP6 is used for these predictions. The predictions are for the period 2081 to 2100 compared to the average of 1995 to 2014. 1227. Ocean warming is projected to push the tropical Indian Ocean into a basin-wide, near-permanent heatwave state by the end of the 21st century, where marine heat waves are projected to increase from 20 days per year, 1,970 to 2,000, to 220 to 250 days per year. 34. Similarly, in the western North Pacific region, model projections show the mean duration of marine heatwave events rising from about 11 days, 1982 to 2014, to about 138 days per event, and annual marine heatwave days rising to about 270 days by 2100 under high emissions. 35. In June 2026, the 4th annual edition of the Indicators of Global Climate Change study, published in Earth System Science Data, introduced a dedicated marine heatwave indicator for the first time. According to its authors, the number of marine heatwave days more than tripled globally between 1991 and 2025, with 2025 alone recording 65 such days, 36. List of events. Sea surface temperatures have been recorded since 1904 in Port Erin, Isle of Man, 4, and measurements continue through global organisations such as NOAA, NASA, and many more. Events can be identified from 1925 till present day. 4. The list below is not a complete representation of all marine heatwave events that have ever been recorded. Impacts. Many species already experience these temperature shifts during the course of marine heatwave events. 23. 25. Many increased risk factors and health impacts affect coastal and inland communities as global average temperature and extreme heat events increase. 43. Changes in the thermal environment can have drastic effects on the health and well-being of terrestrial and marine organisms. 1943, marine heatwave events increase habitat degradation. 44-45, change species range. 19, complicate fisheries management. 17, contribute to mass mortality. 10-9-7, and generally reshape ecosystems. 5-15-46, marine heatwaves alone are estimated to have caused USD 6.6 billion in fisheries losses between 1985 to 2022. Fisheries and aquaculture remain largely invisible in disaster assessments, despite providing livelihoods for 500 million people. 47. Habitat degradation occurs through restructuring and sometimes complete loss of habitats such as seagrass beds, corals, and kelp forests. 44-45, these habitats contain a significant proportion of the ocean's biodiversity. 19. Changes in currents and thermal environments have already shifted many marine species ranges away from the equator. Large range shifts, along with outbreaks of toxic algal blooms, have impacted species across taxa. 9. Management of migrant species becomes increasingly difficult and food web dynamics shift. SST increases are linked to a decline in species abundance, such as the mass mortality of 25 benthic species in the Mediterranean in 2003, sea star wasting disease, and coral bleaching events. 10-19-7, marine heat waves in the Mediterranean Sea during 2015 to 2019 resulted in widespread mass sea life die-offs in 5 consecutive years. 48, repeated marine heat waves in the northeast, clarification needed. Pacific led to dramatic changes in animal abundances, predator-prey relationships, and energy flux throughout the ecosystem. 5. Marine heatwave events were expected to impact species distribution. 31, 610. The Great Barrier Reef experienced its first major bleaching event in 1998. Since then, bleaching events have increased in frequency, with 3 events occurring in the years 2016 to 2020. 54. Bleaching is predicted to occur 3 times a decade on the Great Barrier Reef if warming is kept to 1.5 degrees Celsius, increasing to every other year at 2 degrees Celsius. 55. With the increase of coral bleaching events worldwide, National Geographic noted in 2017, in the past 3 years, 25 reefs, which comprise 3/4 of the world's reef systems, experienced severe bleaching events in what scientists concluded was the worst ever sequence of bleachings to date. In a study conducted on the Hawaiian mushroom coral Labactis scutaria, researchers discovered that higher temperatures and elevated levels of photosynthetically active radiation, PAR, had a detrimental impact on its reproductive physiology. The purpose of this study was to investigate the survival of reef-building corals in their natural habitat, as coral reproduction is being hindered by the effects of climate change. 57. Marine heat waves in the tropical Indian Ocean were associated with dry conditions over central India and an increase in rainfall over South Peninsular India in response to marine heat waves in the northern Bay of Bengal. 59. These changes are transmitted by monsoon winds. 60. See also, effects of climate change on oceans. Heat wave, prolonged period of excessively hot weather. The blob, Pacific Ocean, warm water mass off the Pacific northwest coast. Ocean heat content. Energy stored by oceans. Sources. This article incorporates text from a free content work, licensed under CC by 4, License Statement Permission. Text taken from the Impact of Disasters on Agriculture and Food Security 2025, the Food and Agriculture Organization of the United Nations. References. Jump up to 12 Matthews JBR, Mollevai, Van Diemen R, Fuglestvedt JS, Massendelmet 5, Mendes C, Semenov S, Reisinger, A 2021, Annex 7, Glossary,